Okay, so let's look at this. It's clearly not a type 1 improper integral because we're integrating over a finite interval here. So let's see if it's a type 2 improper integral. In other words, let's see if we have an asymptote. In other words, we need to see whether or not x squared minus x minus 2 is ever equal to 0. So let me just take a minute to do that. So x squared minus x minus 2. Okay, we need to figure out what the zeros of this are. Now, you could use it using the quadratic formula. I'm just going to complete the square, which really is the same thing. So this is x minus 1/2 squared minus 1 over 4 minus 2. So this is x minus 1/2 squared. Okay, minus 1/4 minus 2. So this is minus 1 over 4. And if I want to get a common denominator, 2 is 8 over 4. And so this is equal to, we come down here, this is equal to x minus 1/2 squared minus 9 over 4. Okay, and I'm going to record this information for just a moment because I think I might try to do this problem multiple ways. So this is x minus 1/2 squared minus 9 over 4. So I'm just saving this for later. Okay, so ignore that for now. So now I want to look at this. I want to set this equal to 0. I add 9 over 4 to both sides. I get x minus 1/2 squared is equal to 9 over 4. I take the square root of both sides. I get x minus 1/2 is equal to plus or minus, x minus 1/2 is equal to plus or minus 3/2. Okay, if I do, well, let me just say it this way. X is equal to 1/2 plus or minus 3/2. Okay, if I do the minus solution, I have 1/2 minus 3/2. So 1 minus 3 is minus 2. Minus 2 over 2 is minus 1. And if I do plus, I have 1/2 plus 3, that's 4. 4 over 2 is 2. Okay, so another way I could write this polynomial. So I could write this polynomial in another way as x plus 1 times x minus 2. I'm going to record that information here as well because I don't know which way. Well, I'm going to do this problem multiple ways. X plus 1 times x minus 2. Okay, so there we go. So now we do see that it is an improper integral because there is going to be a discontinuity when x is equal to 2 and when x is equal to minus 1. The minus 1 isn't a problem because we're integrating from 0 to 4, but the 2 is a problem. And so we're going to have to look at this integral. Okay, so now what has happened, so this is going to be a slightly long problem because I'm going to try to go over things in some detail. But what's going to happen, so pictorially, this is the left endpoint, this is the right endpoint, and we have the discontinuity or the asymptote there. So we're going to have to do the improper integral from 0 to 2. We're going to have to compute that, get a number or not get a number if it doesn't converge, and then compute the improper integral there, get a number or not a number if it doesn't converge, and then that's going to be the answer here. And so let me just point out that for this integral to converge, the integral from 0 to 2 has to converge, and the integral from 0 to 1 has to converge. So once more, for this integral to converge, the integral from 0 to 2 has to converge, and the integral from 2 to 4 has to converge. So I have to make sure or determine if these two integrals converge independently of one another. So if just one of them fails to converge, then overall this integral will fail to converge. Okay, so let's look at this. I'm going to do the 0 to 2 integral first. So yeah, so let me just write, so let me do the 0 to 2 integral. So I'm going to do the integral from 0 to 2 dx, and I'm just going to write this as x plus 1 times x minus 2. This is equal to the limit as t approaches 2. And notice I'm approaching 2 this way. So I'm approaching 2 from the negative side. The integral 0 to t dx over, x plus 1 times x minus 2. Okay, so I want to do this integral One way that I have it written here suggests partial fractions. So let me do a little partial fractions scratch work down here. So I'm going to have 1 over x plus 1 times x minus 2. Okay, these are linear factors, so this is going to be a over x plus 1 plus b over x minus 2. Okay, if I clear denominators, I end up with 1 is equal to a times x minus 2 plus b times x plus 1. If I plug in x is equal to 2, this goes away, so I can't put my hand on the other side of the glass here. But if I plug in x is equal to 2, this term goes away, and I'm left with 1 is equal to b times 2 plus 1. So b is equal to 1/3. And if I plug in x is equal to minus 1, this term goes away, and I'm left with 1 is equal to a times minus 1 minus 2. So a is equal to minus 1/3. Okay, and so this integral then is equal to the limit as t goes to 2 from this direction, 0 to 2. I'm going to have 1/3 over x minus 2 minus 1/3 over x plus 1 dx. Okay, and so now I'm just going to compute this integral. I've got my 1/3 here and a 1/3 there. I'm going to pull both of those to the outside of the limit here. So this is the limit, or 1/3 times the limit as t goes to 2 from the negative side. Okay, and the antiderivative of 1 over x minus 2, this is the natural log of the absolute value of x minus 2, and then minus the natural log of the absolute value of x plus 1, and we're evaluating this from 0 to 2. Okay, so this is equal, or sorry, not 0 to 2. That should be a t, and this should be a t. So this is equal to 1/3 times the limit as t goes to 2. Okay, I can use properties of logs here. So this is the natural log of the absolute value of x minus 2 over x plus 1, and we're going from 0 to t. And then finally, or not finally, but next, this is 1/3 times the limit as t goes to 2 from this side. If I plug in t, I'm going to get the natural log of t minus 2, the natural log of the absolute value of t minus 2 over t plus 1, like this. Notice for these values of t, t plus 1 is always positive. T is less than 2, so t minus 2 is negative. So this is just 2 minus t over 2 plus 1. And then minus, if I plug in 0, I'm going to get the natural log of the absolute value of 0 minus 2 over 0 plus 1. Again, 0 minus 2, that's minus 2. 0 plus 1, that's 1. So this is the natural log of 2 here. So I'm doing minus, and I'm having to combine stuff here because I'm running out of room. So this is minus the natural log of 2. But now I have a difference of logs, so it's just going to be log of this divided by that. So log of 2 minus t over 2 plus 1. 2 plus 1 is also known as 3. Divided by 2. So when I divide this fraction by 2, I get that. So multiplying the denominator by 2, and 2 plus 3 is 6. Or sorry, 2 times 3 is 6. Okay, and so now we can see what's going to happen here. As t goes to 2, so as t goes to 2 from this side, 2 minus t is going to 0 from that side. And 6 is just 6. So as t goes to 2 from this side, 2 minus t, and therefore 2 minus t over 6 is going to 0 from this side. And that does not exist. This is equal to negative infinity. So in other words, this integral does not converge. So the integral from 0 to 2 does not converge. Since this doesn't converge, it also means this integral here does not converge.